everybody, and welcome in across the continent for another super exciting Exploring by the Seat of Your Pants broadcast. So many of you are joining us for the very first time today, and so if you are tuning in for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. All of our programs go live to YouTube and stay there forever, so if you want to watch in 3 weeks or 3 years and catch some of the coolest scientists and explorers on planet Earth, you can go there and do just that. Now, today you're catching us on a very exciting day because we are continuing our epic series in collaboration with the amazing folks at If Then She Can. This is the greatest campaign ever devised to showcase the coolest women in science, technology, engineering, and math on planet Earth. I can't recommend it to you enough. There's lots to explore and discover there. And all week long, we are joining with some of the coolest ambassadors of conservation in that group. So people that are working to understand and save some of the most threatened species on planet Earth and explore ecosystems that we've never really explored before. Now, before I dive in with our specific speaker, I want to note we do have a Kahoot today. So if you want to play along with a little 4-question quiz between our talk and our Q&A, you can head to that game pin below and do just that. And I will put that in the chat in just a second. Joining us for, I think, the 4th time, we've got Dr. Katy Croff Bell. She is the founder and president of the Ocean Discovery League, working to understand and map our seafloor, the biggest ecosystem on planet Earth and the most unknown. We have had her on so many times because she's one of the best ambassadors for the deep sea that we have ever featured here at Exploring by the Seat of Your Pants, and you are in for such a treat to learn from her today. And so, without further ado, none of you are here to listen to me, so I'm going to turn you over to her. Dr. Katy, welcome into the broadcast again, and thank you so much for joining.
Hi, Jesse. Thank you so much for having me and for all of you to be here today. I'm super excited to talk about the deep sea with you. As Jesse said, I'm Dr. Katy Croff Bell. I'm the founder and president of the Ocean Discovery League. I'm also an If Then ambassador and a National Geographic Explorer. So does that just all happen overnight? Nope, I don't think so. Let's see here. When I was little, I loved to go to the beach. I loved to be on the water as much as possible. But it really wasn't until I got to college that I realized that I could actually do that for a living, for a career. And so when I was in high school, I got to learn how to scuba dive. Again, another thing that was super fun and really an amazing experience. But it wasn't until much later that I had the opportunity to go out on a research vessel. And my very first expedition was to look for ancient shipwrecks in the Black Sea, which is over in between Turkey and Ukraine and that part of the world. And it was absolutely amazing and absolutely changed the course of my life. I knew that deep sea exploration was for me after that. So first, before we get into some of the discoveries that I've made and places that I've been, why do we want to learn about the ocean? So I'm asking you guys, what are some of the reasons why? I don't know how, Jess, you want to run this? If people,
I'm back. So for anyone on YouTube, if you want to chime in, why do you want to learn about the ocean? Our live classes, Mr. Wood's class, welcome in after we got started. Chris Hadfield Public School, Mrs. D'Agostino's class. If you want to chime in the chat, we'd love to hear from you. But why do we want to learn about the ocean? So some of our answers coming in, we've got cool species, cool animals. Maybe there's lots of creatures down there that we want to understand about, or it's a lot of the world. We just covered this with Madeline Howard at the World Wildlife Fund. 70% of this planet is ocean. And so it's most of our world. We're the blue planet. Maybe we should just go explore it just for that reason. There are mysteries down there. Yes, could be animals again. Could be things like shipwrecks we just talked about. So these are some great answers to kick us off, Katy.
Yeah, fantastic. Great answers. And I'm going to have a few more questions for you, so be ready to answer them. And so I didn't hear anything about the water itself. How does water move around the Earth? It transfers heat from the equator to the poles. What is in the water? So what is the chemistry of the water? How is it salty? How does it hold minerals? These sorts of things are super important. And they're really important for understanding what lives in the ocean. Especially because, you know, a lot of people like to eat seafood. It's a really important source of protein for many, many billions of people around the world. And so it's really important to understand it and know how to protect these animals. Also, how does the Earth work itself? So geology is super important to understand the ecosystems, the habitats, and then how all of these things affect people on Earth. And my first love in deep sea exploration, archaeology. Who uses the ocean? How have humans used it? How have humans traveled over it for thousands and thousands of years? and what connections are made on and in the ocean. And there are so many different things that rely on the ocean, from shipping to transportation to tourism, economies, all kind of telecommunications. There are cables all over the ocean so that you can use the internet. All of these things, renewable energy, are super important and very important reasons to protect and conserve the ocean, because we need all of these things. So another pop quiz question. How much of the deep sea have we seen? Jesse just said that the ocean covers about 70% of the planet. The deep sea is 66% of the planet.
Yep.
How much of the deep sea do you think we've seen? Give me a percent.
Do we think? And again, actually, Miss D'Agostino's class, if you guys want to just yell out, you should be unmuted. What do we think?
2%. More.
2%, a few percent, a little bit more. Okay, private chat. We've got 2%. Anyone else? Mr. Wood's class, Chris Hatfield Public School. We can come to you guys as well. We've got 5% coming in, 1% in other places. Let's see, Mr. Wood. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Cool. Okay, so somewhere between 1 and 10%, and I'll stick with 2%.
I'm liking the small numbers, but we've actually got to get even smaller than that. So, can you see the teeny tiny red dot in the middle of this map?
There it is. Wow.
Yeah, right in the middle of that yellow circle. So that teeny tiny red dot is about the area of the state of Rhode Island where I live. And that is about how much of the deep sea floor we have seen if you put it all together. It's 0.001% of the deep ocean, which is astonishingly small. And there's so much of the ocean to explore for all of you to explore. So there's a lot left. So why have we seen so little? Why is it hard to do? What are some of the challenges?
What do we think? You guys have been such a great audience for this, so please feel free, flick on your mic. We'll get you that way. What are the challenges? Why is it challenging to get to the seafloor? Why can't we just go down all the time? Why aren't we at 100% of that seafloor?
Yeah, why haven't we seen very much of it?
We'll come back to you guys. What do we think? Challenges.
Like the pressure. Yeah, the water pressure.
Water pressure. Yeah, it's really dense down there. Pressure's coming in a lot of places. Anything else? What do we think?
The lack of oxygen.
Lack of oxygen? Really, really good. That might come up in a second. Miss D'Agostino's class, what do we think? Oh, are we there?
Everything they just said.
Everything they just said. Chris Hatfield Public School, what do we think?
Too dark.
Too dark. We think lots of pressure. Food.
Dark, no food, lack of oxygen. These are some really smart kids, Katie.
Yep, you've nailed almost all of them. We've got it's cold. We've heard that one. It's dark. You've got to bring your own lights, and you can't really see very far. It's deep, so there's a lot of pressure. It's wet. Electronics really don't like wet. It can also be hot in areas where there are hydrothermal vents. We heard no air. Nobody mentioned salty, but that's also not very good for electronics and robotics. It's far away. It takes a long time to get to places and then to get down to the seafloor, and it's very expensive. So a lot of the tools that are required cost tens of thousands, hundreds of thousands, millions of dollars to buy and to operate. So what are some of those things? What are some of the things that we need to use to explore the deep ocean because it is so cold and dark and deep and far away? What are some of the tools?
Can you just go swimming down there on the bottom? What do we think? Chris,
just go swimming down there.
No. Come on back in. What do we need?
A submarine.
Yeah, yellow or otherwise.
A waterproof flashlight.
Yeah, very nice.
Yeah, robots.
Robots. You guys rock. Okay, I'm going to check in some other classes. Mr. Wood's class, what do we think?
Technology.
Cool technology. So robots again. Yeah.
Waterproof.
A way to get back up.
A way to get back up. Very important.
Yes,
do not do a
absolutely.
Floor. That's no good. Miss D'Agostino's class.
Oxygen tank.
We need oxygen because there's no oxygen. You guys just are killing it. This is like the best audience I've had all year. Thank you so much. Yeah.
I like the way to get back up. You always want your recoveries of your equipment to equal the number of deployments. One major tool that is used is research vessels. So ships have to get out there This is the or the exploration vessel Nautilus, which I used to sail on for many, many years. And you're going to see some of the videos from Nautilus. Multi-beam sonar is really important. So you know how whales can sense things underwater, bats can sense, they put out sound into the environment, and then the sound bounces off things and comes back, and then they're able to make a map of their environment. So we do the same thing with sonar. So this is a system that is mounted usually to the bottom of the ship or a vehicle, and it sends sound out through the water. The sound bounces off the seafloor and comes back up, and you measure the time that it takes and the angle that it takes to come back, and then you can make a map of the seafloor. But you can only know the shape of the seafloor with this technique. In order to actually see the bottom and to see the things that are living down there, you need other tools like submersibles. We heard that one. A submersible is a vehicle where people are inside and piloting, and usually it's not connected to a ship. Remotely operated vehicles, we heard robots from a few of the classrooms. So this is a kind of robotic vehicle where the people are driving it, they're on the ship, and there's a tether that goes from the ship down to the robotic vehicle. So remotely operated vehicles are very important, or ROVs. Autonomous underwater vehicles, or AUVs, are another type of robotic system, but they are not tethered to the ship. You see the lines here, that's just for deploying the system. So this is a system that you program and then you put into the water, and then it swims around and collects whatever kind of data you're interested in. And then hopefully it comes back to your ship, and then you pick it up and you're able to download the data, recharge the batteries, and then put it in again. And low-cost accessible technologies are just starting to be developed right now. So a lot of the ones that I just talked about, the research vessels or remotely operated vehicles, a lot of those are really big and really expensive. So not very many people have access to these kinds of tools. So my team and a lot of groups around the world right now are looking at how can we create tools that can collect similar kinds of data, imagery, video, depth and temperature, a lot of environmental sensor data, how to bring lights down, but have it not cost so much so more people can get involved with deep sea exploration. So these are some of the systems that my team has developed, and we've got some more in the works. And so finally, what kinds of things have we discovered with these kinds of tools?
What's down there? All right. This is D'Agostino's class. We're going to start with you guys this time. Come on in.
Animals.
Animals? What kind of animals?
Octopus.
Octopus? Jellyfish, yeah. So some of our classic animals. Okay, Mr. Wood's class, what have we discovered?
Shipwrecks.
Pressure. Cool. Chris Hatfield?
Titanic.
The Titanic, yes.
Anglerfish.
Anglerfish, cool. Way to know anglerfish.
Yeah.
Okay, we've got coral animals and their habitats from Miss Lada's class at the Peel Virtual Elementary School. I am so surprised we did not get blobfish. That's the first non-blobfish answer we've had in ages. So thank you for bucking the trend, everybody.
Love a blobfish. Yeah, so when I was working with Nautilus for several years, we did a lot of work in the Mediterranean, the Aegean seas. And so I'm going to show you some of the things that we found during that time. So here we are in the Aegean Sea. And this, again, my first love was archaeology. So we found dozens and dozens of ancient shipwrecks. So this one is about 1,500 years old. And from about the Byzantine period. So all of these jars that you see would have carried wine or oil or fish sauce. This was like the 55-gallon drum of the ancient world. These are called amphoras, and that's what people would have used to transport goods around the Mediterranean. We didn't have cars back then. You didn't have airplanes. Ships were largely used to transport goods. Oops. I didn't hear any volcanoes yet. So in Colombo volcano, this is an underwater volcano in the Aegean Sea, very near another volcano called Santorini. So this volcano is completely underwater. Not even a bit of it comes up as an island. And in the middle of it, you have water that's coming up out of the seafloor. So the magma chamber below the crater is hot and has lots and lots of minerals in it. So water can go through the cracks down into the seafloor. It gets super hot and enriched in minerals, and then it comes back up. So you can see bubbles coming up. You can see these chimneys that are covered with orange bacteria. And the bubbles are largely, or 99 point something percent, carbon dioxide. Carbon dioxide makes the water really, really acidic. So something you may have noticed in this video is that there are no fish, there are no jellyfish, there are no corals, there are no blobfish, because the water is too acidic for animals like that to live there. So a really fascinating environment where it's really just this bacteria growing off the hot mineral-rich water. Now off to the Straits of Sicily. This is also in the Mediterranean Sea, just off the coast of Italy. Here we were also studying volcanoes. This is an area where two tectonic plates are moving apart. So you have rift areas, and we were looking for evidence of old volcanic activity, old eruptions. But the thing about exploration is you never know what you're going to find. Even if you're looking for one thing, you might find something completely different and completely unrelated. So in this case, we're looking for evidence of volcanic activity, and we came across an airplane that had been shot down in World War II off the coast of Pantelleria, which is one of the islands of Italy. So no one had discovered this before. Nobody knew it was there. A few airplanes had been lost in a particular battle, the Battle of Pantelleria, and this was one of them. So we were able to tell the Italian authorities about this discovery, and then now they're able to investigate it. And you can see that there are corals growing on it. It has sort of turned into an artificial reef over the last 80 years or so. Now on to another volcano called Kikumjeni. This is in the Caribbean Sea, in the Southeast Caribbean. This is an area where we thought that we were going to be looking for a landslide. Again, great example of something that we were looking for, and then we found something totally different. It was a landslide that we saw on the sonar. So we saw the shape of this big mound of dirt, and we thought it was going to be a super boring dive. But then we got down there, and let's see if I can play that again. You saw all these black streaks. That's, again, bacteria living off mineral-rich water that's coming up out of the seabed. And these mussels were 14 inches long. They're huge. The biggest mussels known in the world. And there were also sea cucumbers and octopus and all kinds of things growing in this environment where we had no idea this kind of ecosystem could exist. Up to the Gulf of Mexico. We were studying some of the natural oil and gas seeps in the Gulf of Mexico, and Hercules, the ROV, was investigated by a sperm whale. This whale just started going around and around and around, and we just stopped and let the vehicle hang there and record it. You can see that's the bottom of it. The mouth just went by, and there's some of the pectoral fins. And this whale is just swimming around and checking us out. Here you can see the view from Argus. It's
So
just
cool.
absolutely incredible.
Totally incredible.
Up to California and the Pacific Ocean, not far off of San Diego. Live whales are incredible creatures. Dead whales are also pretty incredible. When they die, they sink down to the bottom and provide a food source for tons and tons of organisms. So this is called a whale fall. It's when a whale dies and then sinks to the bottom of the seafloor. And then animals colonize the carcass and they eat it. And this one actually had been down for at least a year, I think. When we were looking at it, you can see some of the line that was used by scientists to sink this whale carcass, so they could study it and they could study the animals that eat the meat away. And then finally, once all the meat is gone, bacteria, you can see a lot of white stuff right here on those little blobs. Those are the bones, the vertebrae. And so now it's just being eaten away by bacteria. And so again, another amazing ecosystem on the bottom of the ocean that's supporting all of the life around it. And finally, this is my last little highlight video. All of the ones you've seen previously were collected by Hercules from Nautilus, a big, pretty expensive research vessel with amazing tools. Now, this next video is from the Seychelles in the Indian Ocean. And this video was collected by one of those low-cost deep sea systems that I was talking about earlier to make it possible for people who live in countries that may not have access to those kinds of tools like we have on Nautilus. So a friend of mine, Sheena Talma from the Seychelles, used one of our video systems to put it down. She made a little structure and she put a camera and a light on it, and it went down. And you can see that she's seeing all these amazing shrimp. There's also some bait on it to attract animals to come to it so she can see what's living there. So there were fish and shrimp and all these little amphipods and isopods swimming all around. Eels, all kinds of amazing things. And in just a second, I think we're going to see something super big and awesome.
Yes.
Yes. First documentation of a 6-gill shark in this part of the world in the deep ocean. Absolutely incredible. So just imagine what is in the 99.999% of the ocean that we haven't explored yet. There's so much left to explore and so much for you guys to learn about. One of the projects I did with the If Then group is to write a paper for kids about how scientists explore the deep sea floor. So a lot of the stuff I talked about is in here, and hopefully Jesse will be able to share the link. So this is a paper that was written for students like you to learn more about deep sea exploration.
I've already shared it in the chats, and I will pass it along via email to every single registered class. It's so great. And if you don't know about Frontiers for Young Minds more broadly, it's like the greatest series of articles written with kids and scientists like Dr. Katy together on Earth. It's so cool. You'll love it.
Yeah, it's super cool. And you can also be a reviewer. So all of the papers in Frontiers for Young Minds are reviewed by students, and it's really amazing. So teachers, take a look. I've both written a paper for it and also worked with a class to review a paper, and it's an amazing experience and, really fun and great resources. So there you have it.
There you have it.
You have time for questions?
We have lots of time for questions. First of all,
Great.
before we dive in with questions, we're going to do a little Kahoot together. And before we do that, I just want to say a huge thank you for such incredible footage. What a cool job you get to do in audience. You guys are one of the most participatory audiences ever. So I'm very excited for your Q&A. And I want to note, if you have extra questions you don't get answered during the live show, we've got 20 minutes for that or so, please email them to us at Exploring by the Seat of Your Pants. We'll pass them along to Katy. We'll get your questions answered. Lots of fun to be had. For now, we're going to dive in with our Kahoot, literally and figuratively. So we've got, for those who are new to Kahoot, the faster you answer, the more points you get. And what you win is Katy and I's everlasting respect. So we're going to start with this in a second. And if you want to give us any hints along the way, please do chime in. The more we learn, the better. Let's see. Here we go. Dun, 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 dun. All right. Question 1 in 3, 2, 1. Drum roll. True or false? The deep ocean is the largest habitat on Earth. What about grasslands? What about mangroves? We talked about the percentage of the world that's ocean. We talked about the percentage of the ocean that's deep ocean.
No. 66% of the world ocean is deep ocean.
Right. Yes. Right. So like this is your hint, nudge, nudge, that the answer is true.
Yes.
The way I've heard it in a broadcast before was that 99% of the livable space, like area that creatures can be in on this planet, is in the deep ocean, which is crazy, like just totally bonkers to think about. So way to go, Great Wildcat, for starting with our lead. All right, question 2. The deepest point of the ocean is how far down? We didn't cover this.
I didn't talk about this.
But I want to see what we think. 5,000 feet, 10,000 feet, 20,000 feet, or over 30,000 feet deep, which is deeper than Mount Everest is tall. I think you kids were really good at some of our questions earlier. You might even know the name of this area.
I'm gonna get this.
Let's see. I think so too. They killed it on question number 1. One more second. The answer is yes. So the Mariana Trench is how far down? Like crazy far down. 35,000 feet?
11,000 meters.
Okay, yeah. Sorry, the American talking in metric and the Canadian talking in imperial. This is a very
Good lesson. You can work on conversions here.
Conversions. Oh, dear. Whoa, that completely throws off our scoreboard. Zesty Walrus is in the lead. Also a great name.
Go Zesty Walrus.
True or false? There's life on the ocean floor.
I hope everybody gets this one.
A bunch of pictures of this one, including this glorious worm that we've got here. Look at that creature. Imagine finding that for the first time, which we did
Christmas tree worm.
The 70s, right? Like, it's just truly wild that we discovered things like this and that they're so ubiquitous.
And there's so much more to be discovered.
We're just getting started. Oh, my dog's very excited too. True. Yes, most of you got this right. Way to go, everybody. All right, one more question. Timeless angelfish. We've got a deep sea creature. Okay. Final question. This is multi-select, so there's more than one right answer. Do you have to be a top scientist like Dr. Katy to be on an ocean vessel? Or what kinds of jobs can you have? Is it all of these? Is it some of them? Click as many as you think are correct. I will say we were live at the North Pole last week on the Commandant Charcot vessel, and we talked about all of these jobs. So that's your very on the nose hint. Not even a hint. Yes, all 4 of them. You can be a cook. Yes.
All of them.
All of these ships have a cook. People aren't just making hardtack and biscuits themselves. There's usually some pretty gourmet food on board research vessels like the one that
I'm not sure about gourmet in most cases, but
we'll get you on some different ships. We'll put you on that. Yeah,
exactly.
Fuzzy Cheetah second first for all the marbles is timeless angelfish. Yes, a fish wins. If you are any of these folks, let us know who you are in the chat. Congratulations. And what we're going to do now is dive in with our epic Q&A. So, Mr. Woods' class, I'm going to come to you first. Any questions you have for Katy, you're good to go. Everyone can unmute their microphones and we'll do a few rounds and have some fun. But hey, Mr. Woods, welcome in, guys. Hey! Any questions for Katy?
How do you know that megalodons don't exist anymore if you've only explored 0.1% of the ocean?
We haven't had this in ages. How do we know megalodons don't exist anymore? Yes. No pressure.
Oh, when you put it that way, it's a great question. But they are ancient creatures that went extinct a long, long time ago. A lot of the things that I think we're going to find are on the deep sea floor, but there are new species that are found all the time, even ones that live in the water column. I can't remember the year, but relatively recently, I have a friend in Sri Lanka who discovered a brand new species of whales in the Indian Ocean. So yeah, it's more rare now to find larger animals like that and more common to find smaller ones that haven't been seen yet. But there is still, I think, a lot out there to be learned.
Well, so this is the thing, and I love the framing of this question because every time we go to the deep sea, every time we go to a rainforest, we find new species. They're usually on the smaller side. The whale's a rare example. This is a megalodon tooth, by the way. So if you want the largest shark to exist, they're an amazing, amazing creature. I can tell you that no one wants there to be megalodon more than deep sea explorers and biologists. We would love this to be true. Whenever we date the teeth from whale or from megalodon, they're always multi-million years old. We've never found one that we're like, oh, that's from yesterday.
That one died last week. Yeah. There are no megalodon falls.
There's no megalodon falls. There's no creatures with megalodon bites in them. And so you see that with something like a great white shark, is that you'll see like a clear bite of it in something else, or you'll find sperm whale guts with giant squid inside. We hardly ever see giant or colossal squid, but we know they're out there because of other.
We know they're out there, but just about 6 months ago or so, were you going to mention this? The baby colossal squid.
Yep. So cute. So nice.
So there's an expedition in the Southern Ocean that found the very first seen living baby colossal squid. It's absolutely adorable. Look it up.
Super, super cool. So this is to say that, like, when you have a deep ecosystem like the deep ocean, that's that large, you know, in theory, could there be megalodon? Yes. The evidence, no evidence for it at all. Insanely unlikely. We could find a dinosaur roaming around a rainforest somewhere, but there's not a scientist on Earth who would join you in saying that there is one. So it's very important that we make that distinction, and I love that framing. Thank you so much.
Yeah, great question.
Mrs. D'Agostino's class, come on in and take us away with another one.
Questions?
You're good. You're set. What was that?
What university did you go to?
Where'd you go to school?
Oh, great question. I did my undergrad at MIT in Cambridge, Massachusetts, the Massachusetts Institute of Technology. I did my master's. Oh, at MIT, I studied ocean engineering, and then I studied maritime archaeology at the University of Southampton in England. And then I did my PhD in oceanography at the University of Rhode Island, which is how I ended up here in Rhode Island.
So our students won't know this context, but that was like the who's who of coolest places to do those degrees in the world. So well done. Kudos to you. It's why you get to run things like Ocean Discovery League. Very cool.
Fun fact, ocean engineering doesn't exist anymore as a major at MIT. They smushed it in with mechanical engineering. So you can still do ocean stuff. You can still do ocean stuff.
Chris Hadfield Public School, come on in, unmute your mic, and you're good to go. Hey.
Have you seen the Titanic?
Ooh.
I have seen the Titanic. I went on an expedition to Titanic in 2004. It was one of the...
I'm sorry, I'm just like professional detachment gone. I didn't know that, or if I did, I've forgotten it. That's so cool.
Yeah, I had the opportunity to go on a return expedition to Titanic. It was the first time that Bob Ballard, who discovered Titanic in the first place, went back after the initial first couple of expeditions in the 1980s. So we went back and we went with some archaeologists and chemists to study the degradation of Titanic and the sort of rusticles that are growing on it and how the wreck site has been deteriorating over the years. It was absolutely fascinating.
I bet. I want to put something in context for our students, which is just that broad strokes in the whole world, there's maybe been a few thousand people that have ever been in a submersible of any kind. Like, it's still an exceedingly rare thing to do on this planet. One of the most coveted things for anyone who's really nerdy about the deep sea to do. Go on. Sorry.
I was not in a submersible, so we were using a remotely operated vehicle. Yep. So everybody was on the ship and the robots went down to the deep sea. So just want to make that distinction.
Okay, we have sent down to things. So thank you very much for that. ROVs are more common when we send robots down, and we do these in a lot of key research vessels, but the technology to get a robot down to the Titanic is a lot more than we need for most deep dives. The Titanic is how far down in the water?
It's about 4,000 meters, which is about the average depth of the whole ocean.
Yeah. So a lot of our dives that we featured in some of our programs in the past, if you joined us, are like a few hundred feet, a few hundred meters. The Titanic is much, much deeper than that. It's why it requires much more intense technology to get there. So,
and it takes about 4 hours for the vehicles to get down to the bottom.
Very
You've
cool.
really got to pay attention to the weather, because if the weather starts to get bad, it takes 4 hours for the vehicles to get back up to the ship.
The ocean can be.
But one other thing about Titanic, like everybody reads about it, it's like a crazy story, obviously with the iceberg and everything. But one really thing that struck me when I was there, initially it's the excitement of it. It's super famous. Everybody's heard of it. Everybody's heard the story. But then when you get there and you see some of the artifacts that are on the seafloor, you see pairs of shoes, you see clothes. It really strikes you how significant this event was and how tragic it was for all the people who were involved with it.
It's a grave, right? We've had divers come on
and
talk to us about World War II shipwrecks, and it's amazing from an archaeological perspective. It's amazing from a, wow, we know the story, we're getting a chance to explore, but this is a place where thousands of people lost their lives, and it's really important to put that in context and understand that. We often get questions about why not bring them back up, and the technology doesn't exist to do that for something like a whole ship, but even if it did, there's ethical considerations with that, so I really appreciate that you shared that. Thanks, Katie. The exact opposite question from the grandeur of the Titanic. Do blobfish always look sad? From Aisha. Thank you so much. I love this question.
I don't know. I mean, most of the ones that I've seen look not very happy, but maybe they are. That's just like a resting blobfish face.
I want to note too, I don't know if any of our students have seen a blobfish as they exist on the bottom of the ocean, but they look like a fish. The blobbiness
they look fine when they're in the ocean. It's when you bring them up to the surface that they look really sad. I mean, you would be really sad too if you were happily living on the bottom of the ocean and then somebody pulled you up.
Yep, or vice versa. If they put you down several thousand meters down, you'd look very sad before you got really small.
Yeah, you'd look very different from you now.
We'll take one more from our group online. How long have you been working from Abdul Rahman?
Great question. My first expedition was in 1999 when I was in college. So I have been in and around deep sea exploration for 26 years.
So amazing. Lucky you. All right. We're going to do a whole other round with our live classes. Mr. Wood's class will come back live. Take us away with another one. Hey.
How would you know you're 0.00?
Yes. How do we know we've only seen 0.001%, or how do we get beyond that? What's the deal?
Excellent question. We figured it out two different ways. One way was that I took dive records from the Woods Hole Oceanographic Institution. So they've been doing deep sea exploration and research for many, many years. And so I took all of their dive records from a dozen different vehicles and calculated how much of the deep sea that they've seen. And then I said, well, if there were maybe 100 Woods Hole Oceanographic institutions all over the world, how much of the deep sea would we have seen with that level of resources? So I multiplied it out and came out with that number, 0.001%. And then a colleague of mine was working on a database of all the deep sea dives that have ever been done. It's not complete, but we have a lot of them. We have 45,000 or so in our database right now. And so he took all of the dive records from that 45,000 and calculated a percent or an area of the seafloor that we would have seen with those 45,000 dives, and came up with about the same number. So we calculated it in two different ways. They're estimates. So it's not, super precise, but it's the best that anybody has ever done. It's the largest deep sea database that anyone has ever put together. And so we feel pretty confident in that number.
What a thoughtful, in-depth answer. That was wild. I didn't expect we had anywhere near that level of
Oh yeah, we actually just published a paper on it in May.
Of course you did.
So.
Why not? So cool.
And I've been thinking about using it to write a Frontiers for Young Minds paper, because like the math is actually pretty simple, but the impact of it, like nobody really knew how much of the deep sea floor we've seen. Previously, people would stand up and say, oh, we've seen 10%, oh, we've seen 1%, oh, we've seen 5%, and nobody actually knew until we documented it. Yeah. So there are a lot of things that, you might take for granted that are assumptions that people say all the time, but it's worth it to take the time to actually ask the question and figure it out.
Bravo. That was so neat. Cool. Miss D'Agostino's class, come on in with another one. And then Chris Hadfield, we're coming to you next. Hey, guys.
Are blobfish naturally born of how they look, or is it like a health problem?
So to reiterate about blobfish, what's the deal with them? Why do they look so blobby, Katie? I said
that's just the way they are.
It's all my fault.
That's just how they are.
Have you ever seen a blobfish? So to reiterate for all our classrooms, on the seafloor, the blobfish just look like a fish. It's that the seafloor, the pressure is really, really, really high. And so when we bring them up to the surface, they sort of melt into goo because they're not meant to be at that low pressure. They're not
meant to be at this pressure.
Right?
They're meant to live at high pressure. Yeah.
If you take a person or like an animal on the surface and you took it down several thousand meters, we get really squishy and gooey too, because our bodies aren't evolved to withstand or handle that level of pressure. And so it's just a metric of where you are compared to where you were sort of evolved to be. So I love this question. And I love that you're so keen on blobfish, and explore some other deep sea creatures because they rock. All right.
I wish I knew more about blobfish so that I could impart my knowledge.
Oh dear.
I'll read up before the next event.
So funny. We're going to take one from our online school, and then Chris Hadfield will wrap up with you in a minute, as time flies and you are having fun. So we are near the end of the broadcast. At what meter level does the sea get pitch black? Where do we lose the light? Great question.
Oh, excellent question. And the answer is it depends. It depends largely on how much stuff is in the water. So if you think about, some beautiful photos of the Caribbean Sea, it's crystal clear. Water can penetrate pretty far down to like maybe 1,000 meters or so. About over 3,000 feet. If you think about, if you look at, say, a lake or some rivers, it might look kind of greenish. That's because there's a lot of stuff growing in the water. And all of that stuff absorbs light. The biggest challenge is light. right? And so it gets absorbed by the things that are living in it, the things that are floating in it, and by the water itself. So it depends on how much stuff is in the water, how far the light is going to penetrate. So it could be tens or hundreds of meters, or it could be all the way down to 1,000 meters, depending on how much stuff or the turbidity, how turbid the water is.
That's your science word of the day, turbidity. You don't get that one very often. I like it. Katy, before we wrap up with one final question from our Chris Hadfield School, I want to note again for all our audience, check out the ambassadors page. We've got 6 more amazing programs like this with some of the coolest scientists in the world. If Then She Can, you're an ambassador with that. So neat. This is on our YouTube channel, so you can share it with your friends and family. We'd love if you do our little survey at the end to let us know what you thought. And check out oceandiscoveryleague.org. There's so much to explore there. Katy rocks, as you can tell. So lots of extra resources. Chris Hadfield, come on in and wrap us up with one final question. Hey, guys.
What is the riskiest experience that you've gone through?
Ooh, the riskiest experience.
Ooh, fun question. I was on an expedition in the Black Sea, and a lot of things happened in a single day. And since we're toward the end of the broadcast, I'll keep it short, but we lost an autonomous underwater vehicle. The president of Ukraine came on board. Another support ship lost its power and its bilge pumps, so it started bringing on water and sinking. We had to rescue all the people that were on that ship, put bilge pumps on the other ship so that it wouldn't sink, tow them to shore, and then we went back to look for the AUV that got lost earlier that morning, and the bow thruster lit on fire and burned up, and we couldn't use it anymore. So then we steamed back to Istanbul to drop off the bow thruster and get it fixed.
That's pretty sketchy. That's about as weird as it gets. Yep.
That was my most exciting 24 hours at sea.
That's pretty exciting. That's about as exciting as you never want it to be if you're ever at sea, everybody.
And it was my first time being the chief scientist on a ship.
Jeez. Katy, thank you so much for your passion, your expertise. You are so fantastic. It's such a thrill having you on. Some of our classes have had to wrap up their day, but I want to bring in all our classes to say a big thank you and farewell. If you're on YouTube and you want to scream and yell at home and annoy the principal, you have our permission. But Chris Hadfield Public School, thank you so much for joining today. Thank you, everybody. Have a wonderful day. Bye for now, guys, and we'll see you all soon. Thank you.